To introduce our first presenter, Joe McChesney, Global Products Line Manager with Kaizen. At the end of his presentation, Joe will also be sharing a short video demo.
Thank you, Hope. Thank you for joining us today in this technical session as part of Productivity's Continuing Education series. Today, we're going to talk about a time for change in solvent cleaning. All products that are released either to your end user or your general public must be cleaned. And typically, there's two ways of cleaning, either solvent or aqueous. With today's topic, we're going to discuss what's happening with the solvent cleaning, the government phase out of existing solvents, the EH&S preferred alternative cleaning technology that we can help you with, and vacuum degreasing is quickly gaining global acceptance. It is spreading very fast throughout the United States as people move from traditional vapor degreasing into enclosed systems. Cleaning overview requires quality and reliability for continuous improvements in most manufacturing processes, especially cleaning. And sometimes the parts are cleaned numerous times in your facility before they get to the end result. Your end product must meet specifications to ensure the success of operation. You must have quality, you must have your specifications complied with. Your cleaning method must meet EH&S concerns as well to get the job done. You have to produce clean parts, and you also have to be concerned about the EH&S criteria for your operators as well as the environment. The general types of cleaning that are available in the market today are in-process cleaning, precision cleaning, critical cleaning, preparation for coating or painting, assembly, and final packaging. All these types may exist in your factories today. Again, the two traditional types of cleaning are solvent or aqueous. Some people like solvent, some people like aqueous. Why choose solvent versus aqueous? The end user confidence of cleaning results. In some cases, one process is generally perceived or proven as superior to meet your application, such as your process or your lubes that you're removing or your contamination levels. And it's also why the government recognized the need for solvent cleaning and enacted certain laws to preserve this process until a better method is discovered. Why solvents? For cleaning, the specification for precision and critical cleaning requires no contaminant or rinse water residue on the end product. You may be able to get there with a lot of different rinses, but solvent gets there quicker and better. Solvent usage is continually growing due to the inability of water to perform in certain criteria, such as component space and restrictive drying processes. The surface tension of solvent allows it to penetrate and go where water will never go and come out just as quickly, bringing out the residue with it. Materials compatibility is a major concern where solvent is superior. Multiple types of metals. Sometimes the aqueous products react with different types of metal, and you must be very cognizant of that. Basic degreasing applications. General metal cleaning. This is like stamping, low-end, non-critical, multiple use, multiple applications. Performance, reliability parts. Now we're getting into higher value parts processing, such as aerospace, military, automotive, medical, etc. Critical clean. Device failure is catastrophic. Now we're in the very high end that is very concerning to the end user that puts out the products. They must meet the absolute criteria, such as automotive. When you look at some of the components and the shapes and sizes and the new changes in lubes and conditions that are being enforced by the manufacturing methods, it's more difficult to clean. Medical is highly restrictive in regard to residue that can be left on the products. And if you look at the sizes and the shapes and forms, again, very difficult to clean. Solvent does a much better, quicker job. Precision cleaning. Shapes, sizes, bearings, blind holes, cavities, different types of metal. Solvent does an equal job on that. Aerospace is huge in regard to leaving no residue, no water, due to the fact where the planes go or what's going through the lines, and such as the hydraulics or the liquid oxygen or any of the fuels. If you're using legacy solvents, pending changes in state and federal laws governing the use of those solvents, such as TCE, Perc, NPB, or HFCs, and others. The EPA, OSHA, and especially the state of Minnesota just enacted laws that basically is going to require you to rethink how your company can effectively meet your parts with cleaning requirements. New solvents versus older solvents. Most solvents, old and new, can clean. That's what they do. However, a lot of solvents being phased out are becoming more regulated in terms of personnel exposure limits and air emissions, and this is happening nationwide as we speak. The main difference is environmental and health characteristics of the solvent being used. You need to be cognizant of that and be looking. And users today are evaluating these new options in order to provide a safer workplace. New solvents versus older solvents. The new solvents have favorable environmental properties, higher part per million, low VOC limits, low global warming. The operational temperature is lower, less energy is consumed. Parts are not subject to high temperature degradation. Global warming potential is much lower. And this is a key highlight now in the environmental industry. Everybody's looking to global warming potential of the products being used to clean with. The surface tension, as we spoke about earlier, wettability, the ability to penetrate and bring out the contaminants and then dry with no residue inside, and so no carry out of the solvent coming out. Personnel exposure limits. This is also a big one. The higher the personnel exposure limits, the safer the product, the safer the workplace, less your operators are exposed to. Today's vapor degreasing solvents are ideal for a wide range of applications. They're formulated to replace ozone depleting, chlorinated, brominated, or other solvents that do not have favorable EH&S properties. They offer performance in today's industrial market. Today's lubes have changed drastically. People are going away from chlorinated lubes. They're going to different types. And the new solvents are designed to affect those lubes quickly and compatibility-wise. Today's vapor degreasing solvents, they meet critical performance. They're environmentally focused. They comply with all federal, state, and local regulations. And again, you must comply with these regulations. Some of the older solvents are HAPs. Some of them are VOCs. You must need to look at the criteria of what you're using and make sure you meet with today's regulations. The heat is coming for the older generation solvents. If you've listened to the Pointer Sisters or in the Eddie Murphy movie, Beverly Hills Cop, the heat is coming. Gone and gone solvent list. AK-225 is gone. It's been phased out by the U.S. government and disappeared, and some people are still using it, but that supply is dwindling fast. NPB is going fast. The toxic concerns, and it's basically being recommended by the ACGH down to 1/10 of a part per million, which most degreasers, traditional degreasers, will not comply with. TCE toxic concerns, same thing, going fast. It's been classified as a known human carcinogen now, and so at that point, it's going to be regulated even more stricter. And at this point, it just recently got banned in the entire state of Minnesota. Methylene chloride, toxic concerns, same thing, very low part per million exposure limit. It is also going fast. HFCs, hydrofluorocarbons, by the EPA, NASA, and the DOD has basically said the use of these solvents is unacceptable and they're subject to being phased out or replaced by newer solvents. So if you're using any of these solvents, now is the time to start looking about changing because the clock is ticking. Consider the future now. All these have a target on them, and they're going to be looked at from every state. As you know, TCE's been banned in Minnesota. I'm sure that's going to spread to other states. Environmental news alert. If you look at the legacy, TCE is now a known human carcinogen. The EPA is putting out alerts and warnings telling people that basically they need to start changing from this solvent. NIOSH, division of OSHA, is adding chemicals to skin notation profiles, asking companies to alert their workers of the health risk of skin exposure to chemicals. And they have a list of these chemicals, and two of them on the list are NPB and trichloroethylene, typical degreasing solvents. HFC's been deemed unacceptable by the EPA. Again, the DOD, GSA, and NASA issued a final rule basically saying the time is to implement the replacement of these solvents because the newer solvents on the market can replace these very easily with no ramifications to either cost or performance. All of these documents are public documents that we can help you find if you need copies of them. The EPA and TSHA, Toxic Substance Control Act, the first 10 chemicals that were listed in 2016 and then basically brought to scope in 2018, 5 of those chemicals are cleaning solvents. 1-bromopropane, which is commonly known as NPB, methylene chloride, N-methylpyrrolidone, NMP, perchloroethylene, Perc, and trichloroethylene, TCE, 5 solvents out of the list of 10. And guess what chemicals made all the list on pretty much all the regulations and alerts? NPB and trichloroethylene. And I singled these chemistries out because they're the most predominant used in today's general degreasing world of industrial degreasing. 2020, TCE was classified by the EPA as affecting organs systems. Carcinogenic, and this is documented and proven. If you're using this chemistry in your plant, you really need to take a hard look at it. And that's why Minnesota was the first state to ban TCE as of May this year, excuse me. And it will be banned statewide with only certain restrictions that will allow it to proceed forward. Typical vapor degreasing will not be one of those restrictions. And what you probably don't know about NPB, but you should, is the OSHA is sending out letters recommending the elimination of the use of NPB from the workplace and be replaced with a less toxic or less hazardous material. The fact that OSHA considers it toxic and hazardous made you questions you need to consider. ACGIH has recommended the personnel exposure limit be set at 0.1 part per million. Very, very difficult to reach that level. And it's being phased out in Europe and Canada. In Europe, there's 14 days left as it sunsets. In Canada, it's the end of the year. So you know that if it's being phased out worldwide, it's going to eventually wind up in the United States being on the hit list as well. The big E concerns, environmental ecology. For no matter how you clean, this is going to affect your operation. The EPA, OSHA, and ACGIH guidelines basically deal more with the environment and the personnel exposure. The VOC content, permit limits. You have to have a permit stating how much pounds of VOC you use per year in your plant. The lower the VOC, the less likely you are to basically exceed your permit limits or the cost of the permit and inspections. Global warming potential. This is getting to be huge in certain areas where water is not an available process. Basically, energy is hard to come by and regulate it. So everybody's looking for global warming potential to be reduced. And the carbon footprint, the energy consumed in operation. This is a busy chart, but if you look at the OSHA occupational exposure limit, the higher the better. So when you look at the chemistries that's in today's market, you have Perc, going from left to right, you have Perc, TCE, MPB, HFE, AK225, HFCs, 4310, modified alcohol, trans blends, and HFOs. The 3 solvents that stand out as being the highest are the HFEs, the modified alcohol, and the HFOs. The other solvents are either being banned or have been banned and have targets on them. And why are they targeted? Because they're toxic. They're labeled toxic by the EPA and OSHA. Global warming potential. When you look at the solvents, the same solvents, you start looking. The modified alcohol is extremely low. The perchloroethylene is fairly high, and that's why the target's on it. TCE's been banned in Minnesota, although the global warming potential is different, lower difference. NPB is very low because of the chemical makeup, but it has a target on it because it's toxic. HFEs, AK225, the 4310, The target on the HFCs is what brings it into regulation. It is extremely high global warmer, therefore it's not desired, and at that point it can be easily replaced by the HFEs or HFO solvents. And when you get all the way to the right, the HFOs is a global warming of 1, almost non-existent. Common vapor degreasing solvents. If you look at the chart, and this is what most people use throughout the United States and even around the world, you have TCE that's been banned in Minnesota, and it's basically on the #1 chemistry on the TSHA list that the EPA is going after. The part per million is still fairly reasonable on most of the solvents, with the exception of NPB. But when you look at what's on the TSHA list, all those solvents are subject to regulation or restriction or final phase out. What's going to survive, in my opinion, will be the trans blends, which basically they're still VOCs, but they're not HAPs. They also have a reasonable personal exposure limit of 200 part per million. The modified alcohol is a low count VOC. It also is not a HAP. It has a higher part per million exposure limit, and also it's enclosed inside the machines. The the HFO solvents are not VOCs. They're not HAPs, and they have a high exposure limit. So all these solvents basically would apply to replacement based on the application. That's where you need a little assistance in someone looking at your process and helping you understand the rules and regulations and what's available on the market today. Vapor degreasing solvents, the most important factors to consider are safety. We want all the personnel that's using these solvents are involved in the cleaning end to be safe. The performance has to be there. The solvent has to clean. They have to provide clean parts at an exceptional rate. Compatibility substrates. Solvent is very superior here. It has much more forgiving attributes. Global warming potential has to be considered. Ozone depletion has to be considered. The VOC content, the personal exposure limits, the ability, and next is the price. You have to produce parts, you have to make money, and you have to control your operational cost. And technical assistance, either from the solvent suppliers or from the equipment suppliers that you're working with, or companies like Productivity that have experts in your immediate area that can help you. Modified alcohol can meet your goals and requirements. Why? Because it's excellent cleaning for both polar and non-polar soils. Polar soils are like water coolants or lubricants that are highly water-based. Non-polar soils are more oil-based type coolants. And Dean will get into this in his presentation a little bit later. The effective precision cleaning, the modified alcohol provides excellent wettability for tight geometries. That means it can get in and out of your parts no matter how they're racked or basically bundled in baskets. It's non-HAP. HAP is a hazardous air pollutant. It's not regulated by the EPA as such. Has low VOC emissions. It meets application-specific cleaning specifications. Cleaning prior to painting and bonding. It can also provide rust preventative and protection with an additive into the solvent. And you can reuse this solvent over and over and over, and at a low consumption based on the machine design, cut your purchased items by considerable. What is modified alcohol? It's a water-free solvent with excellent cleaning power. It's a single chemistry with both polar and non-polar properties. It's one chemistry that cleans parts made with oils or water-based coolants. So this means you can clean your various products in the same type of machine. You don't have different machines. You don't have different chemistry. That in itself is a time and cost savings. It's distillable and highly recoverable. So you're not dumping your bath. You're not throwing it away. You can take the soils and contaminant out through the distillation process and reuse the solvent over and over and over. The environmental qualities of modified alcohol. It's non-haz, biodegradable organic solvent. It meets it's ROSE compliant, CFC free, it's halogen free, it's REACH approved, it's non-flammable, it's not a HAP, and it's proven, if you're doing medical parts, it's proven compliant to the ISO spec for in vitro cytotoxicity. So all these certifications are there, and it's being used worldwide for all these applications. The sustainable future, today's new solvents are replacing the older generation in some aqueous cleaners at a rapid pace. Why is that? EH&S conditions most time. Corporate and government says that this is what we're going to go with or what will be allowed. The cost of operations is huge. When you start looking at the ROI and you look at your energy cost and your chemical consumption and the cost to process your waste streams and also the cost to do EH&S concerns for your operators, the modified alcohol and enclosed degreasers offer the most bang for your buck. The compatibility of new components. The modified alcohol is very inert. It basically is compatible with all types of metal and removes most lubes very quickly and easily. The progress in new vacuum degreasing systems is help move this toward that method of production. They use considerably less solvent. They generate very low emissions to the atmosphere. They isolate the operator from the process, and as well, they isolate the process from the atmosphere. And they usually incorporate automation for process control. Dean will talk about this a little bit later on. The global market trends that we see worldwide, people are moving to environmentally clean greening for complex and challenging parts. They're moving away from the legacy halogenated solvents such as Perc, TCE, methylene chloride, and MPB. Why? Because EH&S issues. They all clean. They clean very well. They're just going to be phased out of existence within the near future. People are moving away from water-based processes due to consumption of water, the discharge requirements, the energy required to heat the water, the different floor space requirements, the residue that it leaves in some areas, and the cost of operations. They're moving toward closed solvent systems. The benefits of these closed solvent systems, ultra low emissions. This is a huge factor that they use probably about 20 to 30% of the same volume of solvent that you would use in a traditional degreaser. Very low chemical consumption, the concentration of soil, low waste stream. They have onboard distillation systems. It condenses and consolidates the waste stream. Some of them have automatic discharge where the oil comes out automatically and the chemistry is returned back into the system. They recycle the solvent. You're not throwing away your chemistry that you've paid for. You're reducing your waste stream cost. Low worker exposure, safety plus. This is huge in terms of the process is totally isolated from the operator, and you'll see this in the short video as we get into this. This is what I think is the key factor. It's the ability to pull a vacuum to enhance the drying and reduce carryout. When you put a lot of different parts in baskets, and these parts can be different sizes, shapes, or surface geometry, they could be bundled, they can be poured in on top of each other. When you reach down in a basket like that, the parts will be clean and dry when they exit the machine down in the center of the basket as well as on the outside of it. They basically will pull the solvent out of blind holes or cracks or channels, and that part is dry and you're not dragging out the solvent. This is why they use considerable less solvent, and they're very excellent in terms of low emissions. They're a compact footprint. You have a wash, rinse, and dry in one system. Considerable less energy than a multi-tank system, considerable less footprint, and that's valuable to production floors. The variable process, all in one. You basically can have a wash, you can have a pre-wash, you can have a wash, you can have spray and air, you can have immersion, you can have complete 360-degree rotation, you can have a milder degree of oscillation, or you can have it static. You can have ultrasonics on or off. You can have them in different bath cycles. You can have vapor only. You can apply a rust preventative for ferrous parts at the end of the process, or you can isolate the rust preventative mode and just run it in standard mode if you do have parts that need that rust preventative. The parts all come out dry, and you can have the flexibility for all these multiple recipes that you don't have to worry about an operator. Just push a button on the PLC and it picks out the correct cycle. Dean will expand more about this. Why solvent? The old adage that solvent cleans better, faster, and more restrictive places than water can ever reach, that's still true. The fact that today's cleaning specifications for precision and critical cleaning cannot have any contaminant, residue, or rinse water on the end product That's what drives users towards Solvent. Today, Solvent, they feature the highest worker safety ratings. They're developed for maximum cleaning performance. They provide lower global warming potential, lower carbon footprint, and lower energy consumption. And they're approved by the U.S. government and other organizations. How do we green up the cleaning process? We minimize the chemical usage. We minimize the chemical exposure to our operators. We minimize the waste disposal that's going out. We minimize energy consumptions. And when we do that, we all win. There's a lot of information out in the market today. You can get that from equipment suppliers. You can get that from your tooling distributors, such as Productivity. You can get that from solvent suppliers, such as Kaizen. Kaizen and Gossinger will perform the cleaning analysis on your parts to verify results before you make the commitment. That's a good part to basically look at, because you can clean the parts, you can verify they meet your specs, you can have the process developed without interrupting your production on the floor. And the good news is, it's all free. So in summary, you select the cleaning chemistry, which removes the soils from the substrates and allows effective removal of the soil from the wash solution. That enhances the bath life and enhances your cleaning ability. You choose efficient cleaning equipment. And you employ equipment to maintain cleaning solution and recover and minimize the waste streams. With that being said, I appreciate the time this morning. As we get into the seminar later on, if you have any questions, we would love the opportunity to work with you and meet with you. Ethan Mueller is our regional sales manager. He's young, bright young man that can come by and visit you and help you with your situation. I'm going to now play a short video, so that you can actually see a machine in our test lab that is running parts and watch the process as it goes through.
Next, I would like to introduce our next presenter, Dean Benzine, Regional Manager with Gossinger High Volume.
Good morning. Hopefully you can see my screen. Okay. Well, good morning, everyone. Thank you, Joe. Appreciate that. Let's get started with part two of this presentation. So in the industry, you have two common part soils. One would be a water-based soil, in which typically that would be your machining centers, conventional lathes and grinders. And then you have an oil soil, which will be Swiss multi-spindle lathes, much oil found in forming and stamping machines, grinding and honing machines. Just like there's two types of soils, as Joe has indicated, there are two types of washing systems, a water-based system and a solvent-based system. So Kaizen, as Joe had indicated, using their modified alcohol, 6386, has the ability to clean challenging parts that are manufactured either in oil or water. In many facilities, you have a combination of each. So what is a challenging part? In my world, my customers show me many different parts, some of which are extremely challenging. This would be a good example. This is a multi-spindle screw machine part that's machined in brass, and brass fines get into everything. They get into all the internal features and external features of this part. And when you wash them in bulk like this, you can imagine the challenge it is to clean them and dry them. Other challenging parts that are quite common are small holes, whether they be shallow, deep, or blind, be typical of a fuel injection part. If you have blind small holes, it's a very challenging part. Internal grooves, counterbores, and recesses are very challenging. Intersecting holes are very difficult to clean. So we have to bear in mind that not only is it important to get the internal intersecting holes clean, but it's also very important to be able to dry that part properly. Very small parts create a challenge. Tapped holes are particularly difficult and probably the number one culprit. Tapped holes are chip traps, and there are certainly chip traps if they're blind tapped holes. We see a lot of cleaning in die-cast parts, cavities and machine features in die-cast parts of many different shapes and sizes. Medical and dental parts. All stamped and formed parts are applied to an oil soil. Now, not only is it important to have the internal features or the internal components of this assembly cleaned properly, it's also very important that these housings are cleaned properly, or you're going to get product failure. There's also post-assembly pre-paint. This has become a fairly common application. A large part, aerospace or otherwise, goes into an assembly room. When that part is assembled, there's normally grease and oil on that part. And because many of these parts have to be painted in a very heavy-duty epoxy, it is absolutely critical that these surfaces be clean and dry for the paint process. We also see applications in the rebuild and remanufacture industry. So the goal here is to go from dirty parts, depending upon what the part it is that you're trying to clean and dry parts in a cycle time that generally is going to take between 9 and 15 minutes. Now, if you're using an aqueous washer or considering an aqueous washer, it's probably going to look like one of these examples. There are dunk tanks that are fairly popular. They are available in both manual and automatic, where the parts are sequenced through a wash, an ultrasonic, a rinse, and a dry. Then you have the rotary type, which generally is going to take care of larger volume parts. This is a carousel type washer, accepting multiple baskets that go through a wash, rinse, and dry cycle. Of course, you have simple cabinet washers, and then there are linear conveyor washers that are using spray to wash the part as it goes through a wash, rinse, and dry cycle. With the exception of the spray cabinet, what's common in all of these systems is that we're depending on heated air to dry your parts. Now, if you are attempting to clean a part that's been manufactured in oil in an aqueous system, there are challenges because water is polar, oil is nonpolar. And the old adage that water and oil do not mix well applies here. So there's constantly a need to refresh the chemistry, separate the chemistry, check the chemistry, dispose of the chemistry. So if you are using water or considering using water, what we'd like to be able to do for you is completely eliminate your use of water, completely eliminate your typical consumable chemistry costs, eliminate the need for chemistry mixing and change out, eliminate multiple chemistries for different materials. If you're cleaning in aqueous chemistries, many times different chemistries apply to different materials. We want to get rid of your typical waste wash disposal, reduce your energy, by all means, reduce the manual rework. I can't tell you how often I see people sitting on a workbench doing the final cleaning and air drying of parts using an air hose. And of course, if you're using water, like Wisconsin, like Minnesota and many other states, you have hard conditions, so you're going to have to use some type of water conditioning. We want to eliminate that. Now, if you are currently, the majority of your parts are in oil, you're probably using a vapor degreaser. For some of you who may not be familiar with that technology, very simply, the parts are placed in a basket, many different sizes, small parts to large parts. That basket is suspended above vapor, which is being heated from below. That vapor is responsible to remove the oil soils from the part and return it to the bath below. And as the vapors rise, they will go through cooling coils, and then that'll condensate and return to the bath. And then, of course, you have very simple manual degreasers that people are still using in, for instance, rebuild shops. So if you are using a vapor degreaser, what we want to do is, number one, reduce the need to use a hazardous chemical. As Joe had indicated, in Minnesota, TCE has now been banned and many more are on the list. So we want to completely eliminate any use of hazardous chemicals. And if you have a vapor degreaser and have maybe migrated from the hazardous material to a more environmental friendly solvent, you're going to find that the cost of that solvent is extremely high. So if that's the case, we want to eliminate those costs for you. So the product that we're talking about today uses the Kaizen modified alcohol. It is called a vacuum degreaser, and it is operating in a vacuum, and it is what its name implies. It's a space from which all or most of the air has been removed. So from the time that the door is closed in our washer, whether that be a manual door closing or a fully automatic system, that system will be under vacuum. So we have a fully self-contained airtight cleaning system from start to finish. Now, normally when you're washing in these systems, you're using some type of part basket or carrier that goes into the washer. A typical basket is like the first one shown, or the middle photograph where you see the collapsible spring-loaded top. We make baskets in many sizes, ranging from a capacity of 30 pounds all the way up to 1,500 pounds, as you see on the right. Now, your highest efficiencies in washing are always going to be when you can bulk load the basket. These are actual examples from some of my customers that are doing very high volume parts. They need to wash the parts in bulk. And so this, as you see here, is how they go into the washer. So it's important, as Joe indicated in his presentation, you can appreciate the challenge that it is to get the parts in the middle of this bulk basket both clean and dry. Now, very typically, you cannot do bulk washing. Many customers must protect their parts. They have critical surfaces that need to be protected or finishes that need to be protected. So when that is the case, we have numerous different types of part separation tooling that goes into our part baskets. These are just an example of some of them. So to walk through the steps, or the simplified walk through the steps of this, is that you start with your dirty parts. They're inserted into a basket. That basket is inserted into the wash chamber either manually or automatically. The door is closed, a program is selected, start is hit, and within 9 to 15 minutes, we go from dirty, contaminated parts to clean and dry parts, and that's an actual before and after photograph that you're looking at. So let's evaluate and do a Cliff Notes version of what our system, the main system, would consist of. We're going to start with vacuum pumps. In most cases, we use 3 vacuum pumps. We have solvent tanks that contain the solvent, of course. You have a rust preventative tank, which is optional but quite common. You have the wash chamber. For all practical purposes, it's almost like looking at the front end wash machine, clothes washing machine. It's a wash chamber. You have filters. You have a boiler distiller, which we'll get into in a minute. We have an oil separator. We use condensers, and then we have a water separator as well. This is what the wash chamber looks like. Now, this is made in many different sizes to accept single basket to multiple baskets, from small baskets to large baskets. The parts of the basket is inserted and rolled into that cage. We have a drive motor at the center line at the back of that cage, which is programmable, which will allow us to oscillate the basket, predetermined number of degrees, or we can fully rotate the basket 360 degrees or keep the basket static. Let's walk through what a typical wash cycle is going to look like. We have our solvent tanks, and we are going to use for the first wash cycle solvent from tanks number 1 and 2. We're going to spray the parts from below and from above and fill the tank and begin to remove the simple chips and soils that are on the part. That's the first phase. We then drain the tank. We send that solution through a filter for all sake of discussion, that's a 50 micron filter that's picking up the particles we've taken off the part. We're going to return that back up to tanks 1 and 2. We don't really care about the purity of tanks 1 and 2 at this point because it's the pre-wash, what we're going to call the pre-wash. We're going to use that solvent again when the next load of parts comes through. Now the main wash cycle is the important wash cycle. In tank 3 is ultra pure solvent. That is kept separated in tank number 3. We're going to pull solvent from tank number 3, again, filling the wash chamber, rotating the part, oscillating the part, or keeping it static, and also using the advantages of ultrasonics. When that wash cycle is done, we're going to drain that tank, send it through a secondary filter. That could be anywhere from 1 to 25 micron bag filter. And we're going to send that back up to solvent tanks 1 and 2. Now in solvent tanks 1 and 2, now we have a slight contamination in those tanks. The oil that we've taken off the part, the water-based coolant we've taken off the part, and of course the solvent. So what we do is we do a continuous distillation. We pull that dirty solvent from tanks 1 and 2 as the system is running. The boiler is going to heat that chemistry, which consists of the oil and solvent. As it heats, the oil will stay stationary in the boiler, and the solvent, which has a lower boiling temperature, is going to turn into a vapor. We're going to take that vapor, run it through a condenser, and turn it back into pure solvent and return that to tank number 3 so that we're constantly refreshing tank number 3 with pure solvent. And we're going to share some of that solvent with tanks 1 and 2 through a baffling system. Now that we have vapor in our boiler, we're going to use it again. We're going to introduce that vapor into the chamber. That is responsible for doing the final cleaning, but is also aiding in beginning the drying process. When that process is done, we're going to evacuate that chamber and the vapor that's in it. Again, run it through a condenser and return it as pure solvent. If you have some parts in your facility that require a rust preventative system, this is a quite common feature for us. It's attached to the solvent tank, but completely separate. It's generally a 5% mixture of Kaizen rust preventative with the normal solvent. That is injected into the chamber. And again, this is all under vacuum. So we pull a very nice, clean, rust preventative surface on the part versus some people do this after their wash and they're dunking it in very messy tanks, or they're spraying their part with WD-40. This applies it to a point where it's almost not noticeable, and it'll give you a high level of protection if you need it. And that is programmable in the system. So if the first group of parts you're sending through are aluminum and you don't need it, it's not part of the program. When the part that requires the rust preventative system goes through the system, that program will carry a rust preventative instruction. So now the important factor here is, as you remember, many washing systems are going to rely on a heated air dry to dry the part. It's very critical that the parts are dried completely. We are not going to do that. We're going to use 2 of the 3 vacuum pumps. The second one here supplementing the first vacuum. So we pull almost a perfect vacuum in the chamber. And this is going to take care of removing all the remaining moisture that may be on the part. It's a very effective and fast way to clean the part, and knowing, as you saw some of those bulk baskets, that even the parts in the middle of that bulk basket are clean and they're dry. Now we move to what we call the oil separation cycle. So the boiler, let's say that we've been operating, some people fill that boiler in a day, others it takes weeks. But over time, that boiler is going to fill with oil, and it's still going to have some degree of solvent in it. So we're going to need to make room in that boiler. So what we're going to do is we're going to drop the oil from the boiler to a second tank below it, which is called an oil separation tank. We're going to heat that one more time. And when we do, we want to remove the remaining part of the solvent that's in that mixture. That too turned into a vapor due to the boiling process, sent through a condenser, and returned to tank number 3 for pure solvent. So let's talk about some of the benefits you might not realize that come along with vacuum degreasing that Joe has covered. And one is, in a vacuum, you have no air bubble. So a vacuum eliminates oxygen, eliminates air. In an aqueous system, when you're cleaning under atmospheric conditions like your sink at home or your wash machine, you're going to get bubbles. Why is that significant? Because those bubbles, small or large, are going to migrate into the very difficult geometries that we're attempting to clean. So if we can eliminate those voids by eliminating the bubbles, that is a definite benefit in cleaning the part much better. Also, as Joe had indicated, a vacuum lowers process temperatures. In many facilities I visit, they have huge aqueous systems that are blowing all kinds of energy up through the roof, and it's a tremendous amount of energy and cost. So under atmospheric conditions, you can boil water at 212 degrees. If I do that under vacuum, I can reduce that temperature by 100 degrees. So we have significant, in many cases, we have very significant energy savings. The other thing is that the vacuum provides reliable and fast part drying time. We're not going to rely on forced air to try to clean the part. That center photograph is an actual photograph from a customer's facility. He was using an aqueous cleaner, that white washer in the background. When those parts come out, they were still moist. He then puts them into a part spinning system to spin the parts. And when that doesn't finish the job, someone sitting on a bench attempting to clean out and dry the parts with an air hose. And we see that all the time. So the benefit here is to get completely clean and dry your parts without hot air, and doing that in a fast cycle time. Now, the chip management system in this is quite unique and very nice. We use stainless steel canisters that are filled with a bag, a filter bag, which you can buy from any industrial supply house. And typically a system will consist of multiple filters. Here we have 4, but we generally work with 3. So the way this works is we have a sensor on the filter canister. When filter number 1 that is being used fills to its capacity, there is a switch that automatically bypasses it to the second filter. Second filter continues to run, and while it does, we begin to dry the one that we bypassed. And what's significant about that, the reason we dry it is because we want to be as efficient with saving the solvent as we can. So we don't want to pull out a soggy bag out of a filter. So when you pull that bag out while the system is running, because it is bypassed and we can change it, you're going to have clean and dry chips and a clean bag. So this is an excellent way of managing chips, and there's no need to do any type of chip drying or spinning. The other unique thing about this system, as you've learned from Joe and myself, is that it goes through very low solvent consumption because we continuously recycle that solvent. General rule of thumb, for the sake of discussion, because it comes up quite often, we go through about 1/10 of a gallon of solvent for every 10 gallons of oil we remove from your parts. In some facilities, we can remove that much oil easily in a shift. In many facilities, that may take 2 weeks to 3 weeks to get to that point. So at a price, the modified alcohol, if I am correct, it's about $35 to $40 a gallon. 10 gallons in a year, you've got under $500 of solvent use in an annual period. And Joe also mentioned this, but just to refresh, we like using the modified alcohol for all of its definite cleaning characteristics, but on top of it, the environmental aspect of it is exceptional. So it's CFC-free, ROHS-free, halogen-free, non-flammable. As Joe said, if you're in the medical industry, this ISO standard is important, the 993-5, and it is also REACH compliant, which is an international standard. So in your ROI considerations, Joe has covered many of these, but these are basically what I've noted when talking to customers where they find their ROIs. It's eliminating the cost of your washing consumables or solvent costs. the environmental compliance cost and restrictions, your personnel safety considerations, your water and water conditioning costs, costs for your secondary ops. When the first wash doesn't do a good job, you go back and wash it again or blow it out with an air hose. The cost to have somebody add, monitor, mix, and separate chemistries continually. Disposal cost. Some people do this via outside contracting. You could eliminate that cost. The value of your product improvement is a consideration. If you're a contract machining facility, having a vacuum degreasing system like this is definitely a value added that you can present to your customer. We have energy savings. We eliminate assembly problems that are typical when parts are not clean. Floor space considerations. These are fairly compact systems. We want to eliminate the rejection or lost business costs. If parts are not clean or there's things remaining on the surface, you're going to have plating problems. And one of the most important considerations, if you're buying a new system, is it going to meet your current and future needs? This system will meet your current and future needs. So here are the many configurations, just some of them of what's available. We go from a fairly small system, as shown in the upper left-hand corner, to a automated system on the right, a very large system, which is loaded actually with a forklift, lower left. And then we do completely special design systems. The wash chamber in that lower right-hand picture is in excess of 20 feet long. So we have the ability to work through a number of standard configurations or special configurations. So as Joe also indicated, if you do have a challenging part, we can tell you the benefits all day, but there's nothing better than to see the proof for yourself. But so between Productivity, who has a machine on their floor, Gossiger, which has this size system on our floor, and Kaizen, who has a system on their floor, we're able to do test washing for you free of charge. Please feel free to take advantage of that opportunity. And if any of you feel that there are other people in your facility that might want to see this presentation, or you'd like us to come in, for instance, with Ethan and myself to evaluate how we can help you, we'd be more than happy to do that. So with that, thank you very much.
Sorry, Josh has a question. Do you have the ability to customize the mesh of the basket?
Yes, can you hear me?
Yes.
Okay, yes, the mesh size in the basket varies tremendously. The standard size is normally a mesh size of 6 millimeters, which 1/4 inch to 12 millimeters. But we have so many parts that are medical related that are very tiny. We go up from half a millimeter mesh and even smaller. And then some people actually use, it's not uncommon to see people use a stainless steel tea bag that has very tiny holes in it, putting those parts in a tea bag, a canister, and putting that inside the basket. So we have the ability of doing many different mesh sizes.
Thank you.